Prova a parlare, Lore.
Ciao,
No,
benvenuti.
aspetta però, c'è qualcosa che non va.
Buonasera, siamo live. Welcome to the stage. Can you hear me?
Sì, si sente.
Yes,
Possiamo
no.
iniziare con...
As you might not know, because you don't know Schrödinger hat probably yet, we are an international community. This is going to be recorded and it's going to be on our YouTube channels and all the channels that we have around. So because we have a little bit of an international audience, we need the speech, the talks in general, to be in English. So hopefully that's not an issue for anyone, and our speakers as well, which we're going to welcome on stage in a little bit, are also going to give their talk in English. If everything is alright by the audio people, yes? Nick? We're good? Okay. So, if we can see the screen now, or not, yes, now we can see the screen. And, well, thank you for being here. Let me welcome you to Schrodinger Session, which is one of the many things that we're trying to achieve. A session by Schrödinger is a smaller event, pretty much like think of it like a meetup slash workshop slash conference, where we try to go around Italy and soon enough Europe to foster freedom of knowledge and freedom of sharing this knowledge, right? Which is very important to us and I guess to all of you. Schrödinger Hat is a community of developers in open source. Some of us are based in Florence as organizers, but people are from all over Europe, some of them from the US as well. We do open source projects as well, so if you don't want to help us by organizing events or participating actively to the community, but you still want to join some projects, we do open source projects as well. So, you know, just go on GitHub, you can find our organization, Schrödinger Hat, and there's quite a few interesting pieces out there that you can participate into in any language possible. If you don't want to participate in any of them, there is still the chance to bring your own project from home, so that you have your own pet project and you want to bring it in and work on it with other people. You're welcome to do that and try, and the community is going to be very happy about that. We are a group of 6-7 organizers. But the community itself counts hundreds of people, and we're growing. So if you join join us as well. We're going to grow even more. So if you go to LinkedIn and put a like on that page, we're definitely going to appreciate that. And yes, let's welcome the stage with Rusty Graph, which is a mix between Rust and GraphQL. We're going to soon know why. We also have a CFP, a call for paper, open right now, and it's going to stay open throughout the year. That's because we're organizing multiple Schrodinger sessions in Florence, Verona, Torino, Milan, hopefully soon Paris, London, and Brussels, but we don't have dates for that yet. But everything is free and open source, and in the heart of the open source spirit also, our call for papers are open sourced on GitHub. We use GitHub for everything, pretty much. And our finances are also open source. So if you go to a website called Open Collective, you're gonna see our entire balance and accounts and how we spend any single cent that we are being given by our beautiful sponsors and partners that I'm gonna say thank you to in a little bit. So if you want to send a CFP, just scan the code, make a picture of it. You're gonna find it there as well. But you know, you can send anything as long as it's a little bit open source related. That's kind of the really important. Our sponsors for these events are Dato CMS, CMS, Headless CMS, very specifically now, and Lavoro Digitale Italia, an HR firm. They very kindly helped us financially and by giving us advices on how to organize these events, and they helped us throughout the year. Also organizing our bigger conference, which is Open Source Day. We organized Open Source Day 2023 just in March, was it? Yes, March. It was a beautiful conference in Florence, historical Florence, with 350 people, all about open source, and everything was free for all participants, food included, beverages included. So next year, Open Source Day 2024, if you feel like coming to Florence, it's always a great opportunity to kind of do networking, meet, and well, everything is free, so I mean, why not, right? So thank you again to our beautiful partners and amazing partners. Special thanks to our host and supporter for today and the next SH sessions in Milan, eDreams. We couldn't have done it without eDreams and our good friend there, Jetson, who is also part of eDreams, co-organizer of React Milano, and also now a co-organizer of Schrodinger Sessions and Schrodinger in general. So let's thank them as well. In fact, I'm going to ask you for a little bit of an applause for that, because, I mean, people giving spaces and money for free is not a small feat. Thank you very much. So thank you a lot. Because you're participating today, we also believe that knowledge sharing is also knowledge that is gained. We partnered with Libo, which is giving out digital NFT certificates for the fact that you actually participated in studying in this training / workshop / session, so that you can actually prove that you're better than anyone else, which is always important. So yes, you will also receive by the email that you use to register to this event, you will receive the NFT certificate in a few days after the event. Just for you know, so if you receive that, it's not spam, it's a real thing. Just, you know, grab it so you can sell it later when the Bitcoin prices go up again. A little surprise, next month here as well, we're gonna have Eric Wendell, whom is a great piece of the puzzle that is Node.js. He's a core member of the steering committee of Node.js writer as well, and well, he's gonna be here with us. He's also a beloved open source contributor, and he's gonna be here for free as well, which is pretty amazing considering that he comes from Brazil. So if you're free, he's really something that you want to assist to, and he's a great guy, by the way, very down to earth, so incredible person. And with that, I would say you can find us anywhere. So if you want to scan the QR code, there are a few links to our pages and so on, but I would say this would be it. So thank you very much for joining us today, and I would call the first speaker, which is going to be Marco. Perfect. So the first Marco then. Thank you very much, Marco. Okay.
First, put the microphone on. No microphone on. Okay, yes, microphone on, yes.
Hi everyone, can you hear me? Oh, okay. Yeah, cool. Tell me when I can start. Is this live, by the way? Oh, okay. Hi everyone. Yeah. So, hi everyone, I'm Marco, and today we're going to talk about how Rust makes open source easier. So, first of all, a little bit about me. I'm a Rust developer and also TypeScript developer at Prisma, and with these two languages I build cool database tools. Speaking about Rust, it's my favorite programming language, and I recently started a podcast about it. This is the second episode, and you can check it out at ieni.dev/rustship. I also created a free workshop where you can create Rust HTTP servers iteratively, so exercise by exercise, and yeah, it's free on GitHub. And there's also a video of me and Jaga going through it. So, first of all, I want to start with the question, what is Rust known for? The first things that comes to mind are probably performance and safety, because we all know that Rust is a program that you can use to create very fast languages with few bugs compared to other languages. But there's also one more thing I would like to talk about, which is the tooling. And with tooling, I mean the tools that helps Rust developers to develop in this language. So let's see our agenda for today. The talk is structured in two parts. The first one, we are going to talk about Cargo, which is the Rust official package manager, which allows to format your code, lint it, run tests, deal with dependencies, and write documentation. The second part, we're going to see community tools, so tools that aren't maintained by the Rust team itself, but by the volunteers from the community. The first tool allows to detect API breaking changes in Rust code, while the second one, it's a tool I wrote, and it allows to update the changelog and release your project. And we're going to see how all these tools makes the life of open source maintainers way easier. So, without further ado, let's dive into it. I will do a small demo about Cargo. So, I will start by creating a new library. And creating a new library in Rust is very easy. You do cargo new --lib because you want to create a library, and then you're going to name your library. For example, I'm going to name it as hat, as Schrödinger hat, which is the awesome organizer of this event. So I'm going to open this with Visual Studio Code, and let's see what Cargo created for us. The first thing is the cargo.toml, which is kind of like package.json for JavaScript, and we have the name of the package, the version of the package, which is 0.1.0, and then the Rust edition, which is 2021 in this case. We also have the git ignore, because Cargo automatically initializes the Git repository for us, and we have a source directory with the lib.rs file. So you can see that in this file we have a function which is exposed publicly to our users called add, that simply adds two numbers, and we already have a test for it that checks if this function works. So in this case it checks if 2 plus 2 is 4. So let's run this test. To run the test, we do cargo test. Now it's compiling, and it's running the test. Yeah. So you can see that this test, it works, was executed. Now let's create a binary to also use this library we have, right? So a Rust package can be both a library and a binary. When there is the lib.rs file, it's a library. When there is the main.rs file, is a binary. in this case is both. So we create the main function, and we create a sum variable where we use the add function, and we simply print it. So print line 2 plus 2 equals sum. So what I want to do now is to build this project, so the binary, and to do it I run cargo build. So cargo build places your binaries into, by default, into the oh sorry, I need to do one thing. Let's run again cargo build, and it places the binary into the target directory, target debug directory, and yeah, there. So you have the binary hat in this directory. So like in 10 seconds we created the binary and a library, and we also have a test suite. I think that in most languages this is a painful task, right? Because maybe you need to define a makefile, or you need to pick up a test suite, while in Cargo everything is there by default. So if you want to run your binary, if you want to compile and run your binary, you don't need to do it like this. There is a kind of a shortcut, which is cargo run, which will compile and run your binary. Also, let's say that we want to format our code, right? We don't want to format it by hand. Normally, you need to pick up a library for formatting your code. For example, in JavaScript you have prettier and alternatives. So let's make our code ugly. In Rust, you just do cargo fmt, and it's formatted by default. Most projects have the default settings, so all Rust programs are formatted in this way. So Rust projects are very consistent in style by each other. Now I also want to run some lints to my program. So you might have noticed that in Rust it's common to omit the return at the end of the function. But let's say that we don't know this and we write the return statement. Now my IDE is configured so that the IDE catches also lint issues. And by the way, I'm using the Rust Analyzer extension for this. So let's see that if we do cargo build, we already saw that no errors happen, but there is a built-in linter again in cargo, which is called cargo clippy. So cargo clippy will tell you that, hey, you don't need to do return left plus right, you just need left plus right. So we can both do this manually, but who wants to do things manually, right? So there is a shortcut to tell Clippy to fix things by automatically, and you just do cargo Clippy -- fix. This is going to fail because cargo tells us that we have uncommitted changes. So I will just commit everything as we always do, work in progress, and we will run cargo Clippy again. Pay attention to this part. So you see that Clippy automatically formatted our code. Yeah, again, one more tool that you don't have to choose and impose to your users. Everything is built in. Now let's talk about dependencies, right? Let's say that we want to add a new function to make this library even more useful than what it's like now. And we're going to make a function that takes a number and return another number, which is a usize, which is a non-signed integer in Rust. So we need to have the right part, which is a usize2, and to create this right number as a random number, we use the rand library. We don't have the rand library yet, so how do we add it, right? Well, you just do cargo add rand, and cargo will, yeah, you can see here, will download the library from crates.io, which is similar to npm. It's just a registry where there are all open source Rust library. Everybody uses this. So you type rand, and here is your library. Here it is. So cargo here downloads the code from crates.io, and it statically links this code with your binary. So all your libraries will be statically linked, which means that if you give your binary to a friend of yours, you don't need to, it doesn't need to install other libraries. Basically, everything is self-contained inside the binary. Cool. Now let's see what cargo did. We could have done it by ourselves. You don't need to run cargo add. You just add this line to your dependencies in the cargo.toml file you saw before. And yeah, cargo add simply selects the latest version and adds it to your cargo.toml. So that's great. Now the Rust compiler is not complaining. Let's use now this function into our code. So let's open main.rs, and let's create sum2, which is add rand, and we add 1 to a random number, and we print it. Cool. Now, sorry. Okay, this is how you format strings in Rust. And yeah, let's run cargo run. We will see that it prints two numbers. The first one is 2 plus 2, and the second one is the 1 plus a random number. So again, adding a library was super fast, and yeah, we have this advantage that the library is statically compiled. We can see that we have we can see all the libraries we have in our project by running cargo tree. So it gives you a tree of all the dependencies of your project. So the hat binary depends on rand, the rand library depends on all these other libraries, and so on and so on. Cool. So now I want to show how to. Now I want to show another cool thing about libraries that I like is that it's really easy to dive into the source code of your libraries. So first of all, if you hover with your mouse on a library, it gives you the documentation of that function, which is great. But you can also command click on it to go to the definition of your library, and so you can add breakpoints inside your libraries. It's really easy to work with libraries in general with Rust. Now I want to talk about how documentation works in Rust. So normally in other languages, you both write your library and you need to build a small static site, usually, right, that contains your documentation, and you need to maintain it, you need to maybe update it and stuff like that. In Rust, that's not the case, because when you push your library to crates.io, then automatically crates.io also create this docs.rs, like it builds your documentation and pushes it to this docs.rs website. So here you can see all the documentation of the rand library, but it's the same for all the Rust libraries. Every Rust library has the same style of the documentation. You can search for functions, and yeah, my connection is a bit spotty now, but yeah, here we go. Like it's very handy because you don't have to deal with different websites. As a user, everything, you know exactly where to look for documentation and so on. And the cool thing is that you can generate this documentation on your laptop offline. So you do cargo doc and also dash open to open it into your browser, and this will generate the documentation. Both you can see that it's in my file system, and this is the documentation of our library which has two functions, but we also have the documentation of all our dependencies. So for example, here we have the documentation of the run crate, which is the same that of the documentation you will find in the official website, right? So you can run cargo doc before taking a plane and then enjoying your 2-hour focus time without worrying about not having any internet connection, because you can check the documentation of your dependencies like on the spot, offline. But now let's try to make our docs a little bit more beautiful than this. So in Rust, you can basically you add the comment with double slash, as in C, JavaScript, and so on. But if you put 3 slash, what you write is automatically taken as the documentation of the function in this case. So, like in this example, we are documenting this function add rand. So we say that it's a function that adds to a random number, and since it supports markdown, we can have an example section with some code, like for example some hat and rand, which takes, I don't know, 3, and yeah, let's print this number. Cool. So we can write again cargo. I want to show you something. Let's make a typo into our code. So let's remove the first semicolon. So if I do cargo doc dash open to regenerate the docs, we can, so first of all, you can see that the first line of our docs appear into the overview of the function, and if you click on it, you have all the documentation we wrote. This code, however, contains a typo, right? And pretty much in most of other languages, that's it. Some user maybe will fix it with a small PR, or maybe it will remain like this forever. However, in Rust, it's different, because all the code examples of your, oh, actually, I also forgot this triple stop. So in Rust, it's different, because when you do cargo test, cargo also tests the examples of your library. So in the CI, you can make sure that the examples of your libraries are like compiled and the test is working. So let's fix this. Let's run cargo test again, and it works. Regarding docs, I want to show you just one more thing, which is that you can also reference other parts of your docs in your docs, basically other parts of your code. So if you want to say it's like add, but with a random number. So with this syntax, you can command click to other parts of your code. And this is also reflected on your website, because if you go to the docs and click here, it will open the docs of that function. So yeah, you can see that docs in Rust are great, and as a developer, as a maintainer, there's really just one thing that you need to do, which is document your library. You don't need to worry about like the ops stuff, or deploying a static website, maintaining it, and so on and so forth. Last cargo command I want to show for today is cargo publish, which just takes your library and publishes it to crates.io. Of course, we don't want to publish this library, but yeah, it's very easy to share something with the community. So that's everything I wanted to show you about cargo. A small recap. The best thing for me is that you don't need to write make files, and you don't need to write package.json scripts. These commands that I show you are standard, and they work out of the box on all Rust programs. For new contributors, this is really handy because like you don't need to read the README, know how to compile a Rust program or how to test it, and so on. And this is all installed by default. Like when you install the Rust toolchain, Cargo comes with it, and yeah, it's a beautiful life. So now I want to talk about two community tools. The first one is Cargo Semver Checks, which is a project that scans your Rust crate for Semver violations. But what does it mean? So let's say that you have a library that was already published, and you have a public method called hey. What happens if you rename this method to hello? Well, this is a breaking change, right? So if your library was at version 1.4.5, you will not release it with 1.5.0 if you are following Semver, right? You need to pump the measure version. And this program does exactly this. It checks your code and tells you if there are breaking changes. So let's see how it works. You install it in the same way how you install all Rust projects from source, which is running cargo install and then the name of the crate. Again, Cargo will download the package from crate.io and it will build it for you and put the binary in a good place in your laptop. Now let's run Cargo Semver check. So the first 3 lines are just for running this check, while the last one I specified the name of the package I want to check. This is the output that it gives in the previous case. So when the a function has been removed, so it says that a publicly function is not there anymore. It was public, and here it tells you the rule. So if you want to learn more about it online, you can do it. And here is the place in the source code where your library, where the function was. So yeah, if there are errors, it's really handy to look at them. So yeah, this is wonderful as a maintainer because it can prevent many type of errors, many type of cases in which you can break the build of your users. But maybe you're wondering, oh, okay, but how does this work, right? Maybe it's parsing your source code and creating an AST and comparing it. Well, actually, it's a much more simple trick. We saw that Cargo can generate HTML documents by running cargo doc --open. And if you think about it, the HTML docs that you see perfectly describe the shape of your crate. And in theory, just by looking at them, you can see if there are some breaking changes or not. Well, it turns out that with Cargo, you can generate also your documentation in a machine-readable format, which is JSON in this case. So it's still nicely, so it's not stable, but it kind of works. You need the nicely compiler, and here I run this command to generate the JSON description of my lib.rs file. This is a strict version of the output, and you can see that this block describes my function, hey. So it has a name, it has the file where this function was, line number, column, it was a public function, like it's not const, it's not unsafe, it's not a thing. So pretty much it's a full description of the function. So Cargo Semver checks has many rules. One of them is, hey, let's see if the name of this function in the previous version of your library is still visible in the next one. So in my case, I go from hey to hello, and so basically it screens something, and it prevents me from breaking my use. That's it about cargo sender checks. If you want to learn more about it, I interviewed the maintainer in the latest episode of my podcast, Starship. But so now let's talk about releasing new versions. So cargo sender checks makes releasing new version easier because it prevents you from big mistakes, but releasing a new version is still painful. And now I will show you why. So what are the steps to release a new version of your library? First, you need to click a new version number. So let's say your library is at 145. Do you bump the patch? Well, yes, if you have if your changes contains just chores or small improvements. You bump your minor version if you have new features, or you bump the major version if your library, the new version of your library contains breaking changes. Well, this is a bit painful to look manually. You're a bit more facilitated if you use conventional commits. So, for example, you can annotate with the if your commit contains any feature, or char if it's just a small cleanup. But still, you need to look at your commits manually. We have the breaking change problem kind of fixed, but still, yeah, you need to run cargo sender checks manually, check what's the new version number. So once you choose the new version, you need to update this version in your cargo.toml. And if you have one package, it's feasible, but imagine you have a monorepo with many changes, it's a nightmare. You need to update the changelog for every of your package. Here, you need to run cargo publish to publish to graphql.io, and finally you need to create the git tag and the GitHub release if you want to, for example, notify your users about this new release, and if you want to, coexist with the GitHub ecosystem. Yeah, this is painful. I hope I convinced everyone. Can we automate this, right? Can we release our packages from CI, automating everything we saw? Well, yes, thanks to the project I wrote. It's called Release Please, and it allows to release Rust crate from CI with the release PR. So basically, on every release, on every commit on your main branch, it creates a release PR. So this release PR contains a summary of the packages that will be released and the new version. So for example, here we have a breaking change. For it detected the breaking change by running cargo sender checks for you, and so it's bumping the Marco test1 crate from 026 to 030, and it also shows the breaking change in the PR body. So if you didn't notice it, you're still in time to revert it before releasing the package. And it also has 7 changed files because it's updating the changelog, the version number. Actually, all the screenshots you saw before, they were taken from a real release please release. So it creates the git tag, the GitHub release, everything you saw. And when you merge this PR, it means you are ready to release your project. And so in the CI on main, it will release everything: cargo publish, git tag, GitHub release, and so on. Adding it into your CI is really easy. You just check out your repository, you install the latest Rust toolchain, and you run release please by giving him your GitHub token to create PRs and to create GitHub releases, and your cargo registry token. So the token that it will use to authenticate to graphql.io. I just checked before coming here. Release please now is used in 100 projects, so that's great. And that's it. That's it from me. These are my social in case you want to follow me. I share both useful stuff about Rust, but also silly memes like this. Thank you.
Thank you very much, Marco. I have a new mic.
Nice.
Very fancy. So I don't know if people from home are hearing us with mic, but just in case, I don't know, we're still in the yeah. Just in case, we're gonna take question now after another big round of applause for our friend Marco Ieni, because he also has a surname.
Thank you.
And yeah, just in case, please do repeat the questions in case there are.
Sure.
Okay. So any question for our friend Marco? Yes, please.
Two silly questions. The first one is about the linter, the linting about Rust. I'm where to specify one of file.rs.
Yeah, it takes everything. I think normally it doesn't lint for your tests, but there are flags that allows you to specify, like if you want to test it for your tests, you want to test for all your features. That's an advanced topic. But yeah, by default you run cargo lib and it checks all the files.
On these,
Mm-hmm.
as far as you know, a Rust file takes all.
Yeah. So now I remember to repeat the question. This question is about if Rust compiles all your library into all the libraries you depend on into your binary, or if it just takes the part that it uses. So I believe that by default it takes everything and puts it into your binary. Not 100% sure, but I'm definitely sure that there is an option to just take whatever it's needed for your binary. Yes, probably if it takes everything, if is to optimize compile time. So by default, I guess that probably by default it takes everything and puts in your binary to save some time. But then you can specify. Yeah, I think the option is called LTO.
Okay, thank you.
Yeah, you unlock a meme for your question.
Thank you very much. Any other questions? Don't be shy. There are many questions to be had for Rust.
There are many memes too.
Many memes too. So, who wants to win something that I don't know yet what, but winning is important. Like stickers, which are already free over there, but winning them is better.
We have a question here.
Yes.
No, Marco.
Hi.
Great. So when you added the dependencies, you added a fixed version.
Yeah.
And this is because it's a binary. When it's a library, it adds a greater or equal, or it all tries to, how does it work?
Yes.
The dependencies.
So when
libraries.
usually like this. Okay, the question is when you add the dependency, it adds a version. We can show it on screen right now. So we have the latest version, which is 0.8.5. So, and this is the same if you add it to a binary or a library. So this is when you add the dependency like this, it's like saying I want to depend on this minimal version, but I'm also okay with dependencies that respect Semver, that are Semver compatible, but even greater. So there is a cargo.log file, which I will show you right here. And if you look for the round rate, it has this this version here, which and yeah, these in this case they are the same from cargo.toml and cargo.log. If you run cargo update, it will update all the versions that you defined into your cargo.toml in a compatible way. What does it mean? It means that if run 0.8.6 is available, which is compatible, then the cargo.log here will say 6 and you will actually use that version. However, if run as 0.9.0, then cargo update won't update to it. So normally the cargo.toml says this is the minimum version that I accept, but then cargo figures out what's the most up-to-date version which is compatible. And this is why it's so important to have cargo semver check in the ecosystem, because if you release run the 0.8.6 and it contains breaking changes, then your users you break the build of your user. I hope I was clear.
Again, Marco, any other questions to be added there? Okay, welcome. Okay, I have one for you actually. What do you think could be like a really nice start, like open source projects out there, get people started in? I think it's amazing language, so people gotta get started in Rust.
Well, of course, mine release, please.
Yeah, that's a good selling point.
I'm very happy to welcome new contributors, even people that have very little Rust experience. No problem. Yes, I've already done it. There are 2 or 3 people that did their first contribution to Rust in release, please.
Very nice. By the way, and I think he knows about this, Hacktoberfest is coming very, very soon. So it could be a really nice excuse if you want to contribute in open source, get a starting point, which can be writing documentation, writing your first commit as code in some repositories out there. And as Schrödinger hat, we also have 3 repositories, I think, written in Rust, which are very small, very tiny, and very user-friendly as a starting point. One is called Lorem Clipsum. You can guess what it does. The other is called CatTTP, so you can guess that too. And the other I don't remember, but Marco will go and check them out so he can tell us how much we are bad at writing Rust. And when I say we, I really mean I, but community is everything. So blame the community. Any other question for our friend Marco out here? No? Okay, I really wanted to see the other memes though, but you know, yeah,
I don't know.
I mean, it's like that. We cannot go over this. So thank you very much, Marco. It was a pleasure having you here. A big round of applause for our friend Marco Ieni. Thank you so much. And well, I would say thank you for being here and joining us.
Thank you. See you next time.
See you next time. Well, now go and sit. You're going to stay. You don't get to run away. Thank you.
Absolutely.
you.
Check.
Nice. Marco is being heard over the internet. Say the things. You have a very nice catchy phrase so that everyone knows about your beautiful voice. Another round of applause for our friend Marco to the second.
Okay.
Thank you very much. Have a good
Ready
talk.
to rock. Okay.
Go ahead.
Well, welcome. One thing I want to start with, that I was last year at the event in Firenze, the Open Source Day, as an attendee. It was amazing. So I can't wait for one next year. And yeah, I think big applause to that, please. All right, so we're here tonight to talk about GraphQL. We will go through a bit of the history and what actually GraphQL means. And then we will see how to measure performance and why performance is such a big thing in GraphQL. So, well, there are three things in this presentation. During the course of GraphQL Query, one that my boss is interested in, it's near form, so we're hiring. We can talk about that later. And this is who I am. I'm a senior developer experience engineer at Nearform, Node Core collaborator, so I mostly work on the Node.js stack and security, and open source maintainer. Probably you've heard about Fastify. Let's get started. I like to start my talk with definition. So what GraphQL is? Query language for your API. And there are two things that are very important in the statement. One is query language. The other one is API. If I say query language, what other languages think about? SQL. Well, most known one, we have SQL and Cypher. One graph database. So we usually think about databases, but GraphQL is not about databases, it's about applications, query language application. Why is that? We have to go through a little bit of the history to understand why we have a query language, but that's not related to. So GraphQL was created by evolution of the SQL query. It was basically SQL from the front. So when you talk about next stuff, well, 15 years. And this is a paper. SQL was born in 2007. A paper by its creator and talking about the advantages of querying from the front end. This is what it looked like at the beginning. So it was a XML. So at the beginning it was very, very ugly. We're very glad that it evolved. But why the GraphQL? What was the problem that GraphQL needed to? So basically, Facebook was born during a period where mobile phones have a lot of connectivity. So with REST, they had to do a lot of HTTP calls to retrieve. If you check comments, a list of comments, people that are inside a lot of HTTP requests. Period where files had very low connectivity. It was so they said, okay, let's make everything inside one HTTP call. Let's put all the data that we need, big HTTP call, them solved and arrived at the GraphQL that we need. So the cool thing about GraphQL is that it provides driven development. Is that it's the client who decides which kind of data required. This is good because if you have an application, a web application, or you have mobile application sharing backend can no?
Okay. Great. So yeah, it's great because depending on where you are data, and the server is of the front end and all the possible operation client. So how many of you use GraphQL? Like to use this? Yeah, we have a query. Like, and developers have project structure. On the server, you define data structures. And this is what a query looks like. So you query for developer skills, name of all developers. Well, agnostic of the transfer. What does it mean? Have you ever used SOAP? SOAP, like GraphQL, is a transport layer. So it's a way to represent the structure of data, but tell you how to transfer. When isn't a specification, developers mention GraphQL is served over HTTP because it's a protocol out there, and usually post and /graph. I've also seen get and the actual transfer is just as the GraphQL operation, query, mutation. We're going and basically the GraphQL engine that interprets what you string and tries to also going important because we're only query. So GraphQL was just query language. But then they noticed, okay, maybe we can change information on the backend. We can reuse pieces of code. So they invented fragments, which is just a piece of logic that can be shared between multiple queries and mutation, and it looks like this. So you define it as fragment, and the point is that you usually, instead of basically doing this, last name, just write name parts, and you can reuse the same piece in many queries. In Nearform, we help our customer to improve the performance of the application. So we talk a lot about performance, and we go through how to improve of 1% your backend performance, and tools that we usually use are Fastify and Mercurial. So all the code examples that we're going to see tonight are based on that. As we said, like your typical GraphQL application might just look like this. So you have a GraphQL client written in whatever cool framework you use, React, Quick, Angular, whatever you want. We have a backend server that contains the solvers and also the schema of data. And we have third-party API and database. Like this is the simplest representation of a GraphQL application that you can get. So this is a key point. The resolvers are the actual function that are responsible for populating the data that you query from the client. So on the client, you're asking for the list of developers. Resolvers go on the database, go on a third-party API, retrieve that data and send it back to your client. This is what a resolver looks like. So basically, when you ask for users, it's going to return you all the users based on the ID that you passed. So if you want user with ID 1, this resolver retrieves you that user. The thing is that when you have a large application, you want to scale, and you want to have microservices, which are like the coolest trend right now. You want to, like, I'm sure that you all are using microservices in one way or another. And Mercurius, it's like GraphQL in general, it's great because you can split your schemas into microservices, and then you have just one gateway that reroutes all the traffic to the right microservice. We're going to see that. So this is what federation looks like. So you have like your front ends, and you have a gateway, which is very similar to a normal REST gateway, and then you have your underlying services, your federated services. Can be product, can also be REST services, because it doesn't matter for the gateway. Like for the gateway, everything is a resolver. So the gateway knows where to retrieve the data, and if it's a third-party API, it's database, it's another GraphQL service, it doesn't matter. And this allows you to build your architecture, which in very different ways and with different kind of pieces. But let's see how this works under the hood. So gateway actually queries the federated service for the schema. So on startup, when you start your application, the gateway sends a special kind of query to every federated service. So the gateway has to know the IP of those services, and then queries all of them and asks them, give me your schema, and merges it into one big schema. So when you query your gateway, the gateway knows which part of that schema is connected to which microservice, and it's going to reroute that call for you. So I call them virtual resolvers. They don't really have a name, but they are just resolvers. But so basically, it's what we talked about. So yeah, this talk is about performance, but until now we didn't talk about performance. This was just a bit of introduction on the history and like how GraphQL works for everybody. But now we're going to dive a little bit into that. So, how many of you have been in this situation? Like your page is really slow. It's taking a lot of time to load, and you don't know why. So first thing that you do, developer tools. You go on the developer tools, you're going to see network and see, okay, this is slow because of this is slow because of that. But you know, with GraphQL, you cannot do that. Because what you see is just one HTTP call, because GraphQL is passed on HTTP, and there is just one HTTP call for all the data that you're querying. So you only see the total response time, which could be in seconds or minutes if it's bad, and that's not going to help you. So how do we debug that? And also when you have a federation, as we said, we have many federated services. So if just one of them is slow, your whole application is going to be slow. Because the gateway needs to retrieve every single piece of data that you are querying before returning the response. So if one of them has some kind of problem, well, you're going to have a problem too. So where it could be? It could be literally everywhere. Yeah, and this is what happens. So if you're running GraphQL in production and you have a large environment and you have a problem, you need something to find where the problem is, and you need it fast. Of course, it's very important to use tools to monitor performance, metrics, centralized logging, and I'm sure that you all do that, right? But that's something that's kind of expensive, and it takes time to build the infrastructure, and it takes DevOps to do all their DevOps thingy. So you don't have that immediately. So let's see where the problem could lie, because if you're using an application, for example, Node.js, your problem could be in the HTTP layer. For example, you're using Express and your backend is very slow, and like it's taking a lot of time to receive requests and work on them. Or it could also be your API layer. For example, you're using old GraphQL library, so it has some problem into parsing the abstract syntax tree, and or your APIs are not written properly. So there is a lot of factors into that, but also resolvers. For example, you're calling a third-party API from somewhere, from anywhere, or database, God knows where, and that could be slow. For example, it goes into timeout, like that could happen with any HTTP call. So it could be a slow resolver, for example. Could be caching, like you said, caching wrong, so you're not hitting the cache, and it's making it slow. Or it could be, as we said, database. It could be basically whatever. With GraphQL, you have a lot of uncertainties, and if you're using a federation, those uncertainties are spread towards your architecture. So let's see what are the common performance issues. Overfetching, the most common one. Like you're literally asking more than you need. With fragments, we see before that you basically can reuse pieces of code with among other queries. But sometimes we are lazy, so we take one fragment that has, for example, a field more than we need, and we say, well, I have these fragments ready, then why should I create a new one? So we just use it and we ask for more than we need, but if we ask a lot more, that's going to cause a lot of overhead. Or for example, in a federation, if you're asking an extra field that is in another service, you are going to do another HTTP. You are doing an extra HTTP call in the network for that extra field that you don't need. The most important thing is to be careful when using fragments, because it's the most common case. The other one is the slow resolver function. As we said, resolvers usually fetch data from APIs or database, whatever. You need to handle your timeouts properly, and also errors. Like, this is very important because if you have long timeouts, the whole GraphQL call is going to take a lot of time. Caching. I actually didn't write a slide for caching, because caching in GraphQL is such a huge topic that it requires a talk just by itself. In GraphQL, you want to cache everything. You want to cache on the front end, you want to cache on the back end, you want to cache everywhere. Like, it's very important. It's what makes it very performant, because with GraphQL, it's very easy to cache. Because most of the time you're asking for static data, and if you're not, you might want to use subscriptions. So use cache. And the N+1 problem, we're going to see this in detail. This is also a very common problem. I will try to explain as clearly as I can, but it's not the easiest one. Let's see. So imagine that we have this schema that we saw before. We have developers, and every developer has a list of projects. So we will have a list of developers and a list for each developer of their project. So this is what a resolver looks like. Like, imagine I just want to write my first application. Okay, this is how I retrieve developers. Select star from developers. It gives me the list of every developer. Then I'm like, okay, let's write another resolver for developers. Select star from project, where developer ID equals to ID. Okay, so I'm just querying the database for every ID that I receive. I ask for the project. But these results, if we just do the query, so developers and the project, we see that we are actually doing one first query to ask for all developers, and then 3 queries. This is not good, right? Like, you don't want to do all these queries for just something that you could group. So in Mercurius, we have something called loaders, data loaders, which allow you to batch queries. And so we delete our resolver and we create this loader. So it basically does the same thing, but allows you to batch these queries. So the result is that we have just one query when we retrieve all the developers, all the projects. Exactly, and this is very important for performance. Otherwise, you're going to have a lot of troubles because queries are expensive. So you want to group them as possible. And like these are the most common one. So like we can say that it's kinda hard to troubleshoot the performance of a GraphQL application because there are many factors, and probably there are even more factors than using a traditional REST architecture. So exactly, in a federation, the problems like multiply by 10 at least. So the problem are, we can only see the total cost of a query from the developer tools. It's very hard to spot expensive fields, especially if you're using fragments. So generally speaking, we say it's also hard to optimize a slow query because we need the tools to understand why it's slow. SQL, which is another query language, as we talked before, has a keyword explain. How many of you has used the explain keyword? Okay, almost everybody. And you know that it's crucial to understand why a query is slow, what a query is actually doing. So yeah, this is what explain looks like. For every single step, you have time, usage, rows, etc., etc. I really wish there was an explain keyword in SQL, but no, there isn't. This is for many reasons. Usually, application like libraries need to update because standards change and evolve. In GraphQL, it's actually the opposite. People start to do cool things with GraphQL. They become the standard, but they are not standardized by anyone. The last paper that standardized GraphQL was from 2021, and it didn't mention federations and a lot of stuff that the ecosystem has created to update it. So probably one day we will see it, I don't know. So one thing that you really, really want in GraphQL is to track the start and end time for each resolver. Like you know when a resolver started and when it ended. Because then you know how much time it took and if it's slow or not. So in Node.js, we have a very cool thing, it's called process HR time, that allows you to track in nanoseconds the time of something, like start and end. So we would like to compute the total time and return that time to the client. So why to client? Because GraphQL is based on client. Like front-end developers are the real users of GraphQL. So they want to be able to see what's going on from the client. And in Nearform, we actually did it. Because we were working on a big project where we're using GraphQL from an actually Italian company, and they are using GraphQL with Mercurius in production. So we needed to see where the problem was, and we created this plugin called Mercurius Explain, where you can actually see for extra field in the response of the GraphQL response, which has a field explain with a profiler that returns all the performance data relative to the query. And it's a great one because we were able to track everything and see how many times a resolver was called. And it was important to know how many times a resolver was called because we could make sure that we didn't have the n+1 problem. So if we saw that we were doing a lot of resolver calls, maybe we could patch things and improve them. So it has many cool features, but I don't want to talk about them. This is an open source project that you can see on GitHub, and if you want to use it, that would be great. So this is how it basically looks. So for every query, you have like the path, the begin and time in nanoseconds. You have the how many times the resolver has been called. And in a federation, it does that, but it merges this explain field from every single result for every single services that's federated. So you can use that in a federation, and it helps a lot to troubleshoot where you are performance issues. But as I said, GraphQL is for the clients who want to be able to test it from the client side. So how do we do that? So on SQL, you have your amazing benchmark. But for GraphQL, we have GraphQL, which is a simple IDE that runs on your server. And it allows you to test queries in real time, just like this. Hope it works. Yeah, it's a bit slow, but it works. You can test them, and you can see the result of it, and you can also see with the, yeah, exactly, you can see all the fields and everything. And with that, we created a plugin for GraphQL that allows you to see performance from the front end. And this is what it looks like. It's a bit dark. I'm a big fan of dark mode. So on the left side, you have every path. For every path, you see the time, and you have a waterfall, because we all love waterfall on the Chrome DevTools. We have the resolver count, so we see how many times it has been called, and it's open source. So thanks for listening. This was here. You have all my links. Please add me on social media so you can see all the stuff that we do on Node.js and GraphQL, Fastify, whatever. Thank you.
Thank you, Marco. I will stay with that remark at this point. Any questions about GraphQL? Since we're all professionals about this new standard, right? Know everything about it. Of course not. I don't know shit about it. A question. We have a question.
So these were performance tricks mostly from the server side, right? As a client, so I have a couple of questions. So what are some common public GraphQL APIs? I know GitHub has one GraphQL API. I don't know if there are others to play with, and if there are performance tricks that clients needs to be aware in making some requests.
So on the client side, so actually on the client side there isn't much you can do, because other than asking for more fields and caching, that's basically it. It's like asking if you can do tricks on the SQL client. If your database is slow, there isn't much that you can do about it. And big projects that are using GraphQL, like GitHub is probably one of the biggest. Facebook, obviously, is using it. In Italy, we have Tridom, the one that plants tree around. That's used. Like I don't know many projects, but I'm sure there are a lot of them.
Yes. There is open source Wrapped, which is the Spotify open source, which is by Schrödinger head, so you can also go and contribute to that, which is very important. Contributions are essential. Any other questions from Marco? Yes, we have one there. I'll bring it to you.
Okay, it's more specific question actually, that I was wondering if there is some integration with this Mercury and the AppSync, AWS AppSync, that we can use, because we have the custom resolvers that you put authorization layer, then the custom lambdas actually could be very crucial to have.
So the answer is no, because
wait.
The answer is no, because Mercurius is based on Fastify, so it works with the Fastify plugin system, and unfortunately it doesn't work with Update.
So it's a Matthew Hills system. Okay. Very well. Any other questions for our friend? Yes.
A question about the federation, and I think maybe a little bit out of the scope, but it's about performance. If one microservice needs an information by another microservice, they are go to the gateway and are merged there.
So,
Like, I don't know, microservice about user and microservice about the comments. The comments as a user that invite the comment, how they speak each other.
So two federated services cannot talk to each other unless there is a gateway inside, because they don't know where the other federated service is. Only the gateway know the IP address and all the info. So what you like, the gateway knows everything and has the schema of every federated service merged together. So he is the one who knows which field where it belongs to. So it does the rerouting, but they cannot talk to each other without the gateway.
So about the performance, we should be smart enough to write the data in a federation way, if I can say.
So usually you want to have your microservice divided by domains so that each domain is isolated from the other one. So if you need data, you probably want to put, if you need data that's like very strictly coupled, you might want to put that into the same domain, and so create your federation like that. But you can also use REST services too. You can mix them. This is one thing that a lot of people don't talk about GraphQL, is that it gives you the flexibility to mix REST and GraphQL. So if you have one REST services, you can call that, and it's absolutely normal and approved. So
okay.
I hope that will answer your question.
Any other questions? Yes.
So hi, I was thinking about the fact that maybe sometimes you can have like some complex schema, and for example, to query some kind of stuff, it takes a lot of time because it's actually cost expensive. And can that be like a security issue, or maybe someone from the client might inject some kind of query that has some performance issues, and how would you prevent that?
So yes, that's absolutely thing that they do. Like a lot of vulnerabilities are based on the response time of something, and like when they see that something is slower than something else, they might think that there is vulnerability involved into that. So for example, the slow loris attack that was on Node.js, there are a lot of vulnerabilities that are time-based. So one thing is to handle timeouts correctly. So you always want to have your max timeout at, I don't know, like that depends on your application, but you need a timeout that after a certain time it cancels the query from the gateway. Because the problem is that if you are querying something and the gateway has to go through many federated services, it just needs one slow service and the whole thing gets slow. So that's why it's very important to have timeouts and to have caching. So, and that's why I was saying that caching is very important in GraphQL, because most data are static and you just cache them once and you always hit the cache. And so to answer your question, yes, that's very normal, and like handling timeouts is the way you resolve that.
Other questions? No? Yes? Okay, I've got one for you. So, we're talking about microservices, federated services, software anywhere in small doses, in serverless architectures whatsoever, lambdas all the time. It feels like it's put out there as a solution to any problem that a software engineer might encounter, an architect might encounter in general. Do you think so? If not, what is your stance on this thing?
I'm a huge fan of monoliths. Monoliths. So no, like when you're creating an microservice architecture, you know that your architecture is going to be slower than a monolith because there is network between. So you want to be very careful with the tools that you use because they have repercussions, financial, performance, and also based on your team. If you have a small team and they're not experienced, you don't want to do microservices because microservice architecture, it reflects, code in general reflects your organization, it reflects your team, how your team is built. If your team is not built for microservices, it will be a mess. So it's not about the tool, it's about people. And I think that most of the time we abuse those kind of technologies.
That's a great answer. Well, if there are no further questions, and it seems not, thank you again, Marco. A big round of applause, Marco. Thank you very much for being here with us. Another bit, I'm not going to put the slides back because it's going to take like 5 minutes to get the computer there and just show them. So we're going to thank eDreams, ODIGEO again for letting us have this venue for today, and also our friend Gerson and everyone who's been here working towards the objective of having the first Schrödinger Session in Milan. And also, of course, a big applause from myself, my friends, to you, the public. Thank you. And now, si riparla italiano.